right, this is some practical stuff. We have an open top cylindrical can. It's going to have a capacity of 36 pi cubic inches. What are the dimensions if a cylinder is to have a minimum surface area? Okay, in almost every single optimization problem, we're going to have two formulas. One of them is going to be noisy because I'm banging my ring on the desk. One of them is going to be what you know, and the other one's what you don't know. So let's read the problem with that lens. So an open top cylindrical can, well, I do know the shape of the can. It's going to have a capacity of, oh, I know the volume. Lucky me. So I have the volume of a can, and we're going to pull out some old formulas here. We're going to be dealing with the volume of a cylinder. It has an open top. I know that's going to come in handy for the surface area, but if I was to grab a purple pen with my noisy markers and draw this is the cylinder. Basically, it doesn't have a lid, but it still holds the same quantity. So the volume is the same, but it just has a different surface area. That'll come in handy later as we deal with, well, surface area. But the volume is going to be pi r squared times the height. Pi r squared is the circular base times the height. All right, let's plug in 36 pi as our volume. Equals pi r squared h. What are we going to do with that? Well, we're going to solve for one of the variables. And I think the logical one to solve for would be h. And here's why. If I solved for r, I would have to take the square root, and that would just be okay, but would complicate my life just a little bit. And, you know, life can be complicated enough without having to square root. So we're going to divide by pi r squared and divide by pi r squared, and we'll cancel. So h equals 36 over r squared. And notice that the pi's canceled. Okay? All right, let's keep reading. We've only gotten past the first sentence at this point. What are the dimensions? Okay, they're asking for the dimensions of a cylinder, and dimensions of a cylinder usually are measured in height and radius, diameter potentially, but let's go with radius because that's what we use in the formula. What are the dimensions if the cylinder is to have a minimum surface area? So like I said when I was banging on the table, the first formula is what you know. I know the volume. The second formula is what you don't know, and I don't know the surface area. And that is going to be my second formula. Okay, surface area of this cylinder. Well, the surface area of a cylinder with an open top. Now the open top thing comes in handy. So picture a can, and this can has a lid pulled off of it. And so we're going to have a circle on the bottom, and we're going to have this piece all around the edge. It's called the lateral face. And so basically, if you were to take this can and just peel off the label, and the label just covers the can all the way around exactly, perfectly, no overlap, then it would unpeel and it would become a rectangle. I keep doing this with my hands as if you can visualize it. But it would become a rectangle. Rectangle is base times height. Well, the base of this label, as it unpeels, it would really be the same shape as the circle. It's a cylinder, basically. With a cylinder, my goodness, I'm having a hard time explaining this. Here's the word I'm aiming for. Circumference. The circumference times the height. So 2 pi r, that's my circumference times my height. And again, open top, so I only have one circle to deal with here. That's the bottom, not the top. Okay, what are we gonna do now? Well, we keep reading. What are the dimensions? Final answer will be radius and height. What is that minimum volume? Have to find the volume. And confirm that the volume that you found is the minimum. That's gonna involve a little bit of derivatives. It'll be fun. Well, a little bit of sign analysis on the number line. So we need to take the derivative of this, and if you're looking at that, you're realizing we'll have to do the product rule here, and I really want to avoid that, and so do you. So let's not do the product rule. What we are instead going to do is take this, see, that's why we did, and we're going to plug it in right here. So we're going to have A equals pi r squared plus 2 pi r times 36 over r squared. That is h. Let's keep going. I always simplify before I take a derivative. That's just how I roll. So 2 times 36, that'd be 72 pi over r. That's it. And we're ready to take a derivative now. We've been taking derivatives for a very long time, so let's just do it. The derivative of a is 2 pi r. And this is not an implicit differentiation, so you might say, oh, dr dt. We're not taking the derivative with respect to time. A is a function of r, and we're taking the derivative of a with respect to r, okay? Just take the derivative, just standard derivative, no d, dt, this or that. Technically, this is r to the negative 1 if we brought it up, so it'd be negative 72 pi r squared. And oops, to the negative 2. Yeah, like that negative 1 multiplies there. We'd subtract 1 from negative 1, get a negative 2. And we'll set this equal to 0. Let's clean it up just a little bit more. So a prime is equal to 2 times pi times r minus 72 pi over r squared, and that is equal to 0. And we will solve this thing for r. Let's keep going. Let's move this term to the other side. So 2 pi r equals 72 pi over r squared. We'll cross multiply, bring my work up here. That's going to give me 2 pi r cubed equals 72 pi. Divide by 2 and divide by pi. R cubed equals 36. We need the cube root of 36. Let's grab a calculator. And even though I'm going to write down 3 decimal places, woo, I might throw my calculator on the ground. Oops. Dropped it. 3.302. We're going to use 3 decimal places. However, when I actually compute the volume later, I'm going to use that. As a matter of fact, I'm going to use it later, so I'm going to store it. If you press stow, it grabs that last answer and it will store it as whatever variable you want. And I want to store this one as the obvious, r, 3.302. Okay, let's read again. Took care of the first sentence. What are the dimensions? Okay, oh, we got the r. We don't have the radius. I mean, we don't have the height. We have the radius. So we're going to do 36 divided by r squared. Okay, I'm pulling that from here, not making that up. 36 divided by r squared. Well, what I'm going to do is just type that in, and I'm going to get, if I recall correctly, it's the same thing or double. I don't remember. Ooh, it is the same thing. Is that a coincidence? No, actually. In some problems, the way they're configured, that works that way. And actually, just to be clear with the context of what's happening, we're dealing with the dimensions of a cylinder. Set my calculator down gently before I throw it and drop it. Mess it up. There we go. Inches for both of those. If you leave the units off and they ask for units, you will lose points. Well, what is that volume? And then confirm that you found that volume. All right, and we're going to write that one in words in just a minute. I'm running out of space, but we'll be okay. So the volume is, well, pi r squared times height, and I will basically type this in using radius and height. I'm going to store that last value as height, so stow as h. There we go. It actually is the same as r again in this case, so I totally could have done that. But we'll do pi times the radius squared times the height, and I have 113. Whoops. There is a typo in here. And I'm not going to start this problem over. This should say minimum surface area. Whoops. So we have to find the surface area. We already knew the volume. No sense in finding. Like, why am I typing this in? All right, so the area is pi r squared plus 2 pi r h, or any of these substitutions, not the derivative. And what we're going to do is plug these values in for r and h. I apologize for that. There was a typo. This minimum surface area, I'll just abbreviate surface area. And so let's type this in. Wow, that was a massive mistake. Pi r squared plus 2 pi r h. Alrighty, 102.756 what? We're dealing with area, not volume. This is going to be square inches. All right, fantastic. So now we have to confirm that we truly found the minimum. Like, what if this was a maximum instead? Well, glad you asked. Let's use the number line. Okay. Our critical value for, I would say x, but in this case it's r. And let's kind of put this in context. The area is a function of the radius, and the radius is the radius that has a critical value is 3.302. 3.302. And notice I don't have an arrow going in both directions, just on the right side. Yeah, I'm sure there's a threshold where we would have to stop that, but for now we'll just go with it. So the smallest my radius could be is 0, because you can't have negative. And the largest it could be actually is infinity. It could be, it can go forever. So the radius could be infinity, and you would have just a ridiculously short height. Now, not practical in the real world, but theoretically we'll go with it. So we're going to plug numbers into the derivative in both intervals, and you're going to see what's happening here. So let's continue with what we assume would be a calculator active question. And I'm going to type that in as, let's clear out some stuff here. It's having a lot of fun with functions. I mean, who wouldn't, right? 2 times pi times the radius, I'm going to call it x in this case, minus 72 pi divided by the radius squared. And what I'm going to do is plug in numbers from each interval into this, and we'll see what happens. Okay, a number that is less than 3.302, like 1, and I get a negative number. So in this case, a prime is negative. And in this case, plug in a number larger than 3.3, we'll plug in a 4, we get a positive. A prime is positive. And just to prove a point, if I plugged in exactly 3.302, I'm going to get, okay, this is a rounded number, but notice how close to 0 this is. Now check this out. If I plug in r the way I stored it, 0. What? Isn't that lovely? I know, I like it too. So confirm that you found the minimum. We found the minimum. Here's the proof, but not really proof. Let's write it in words. R equals 3.302 is the, let's make it clear, radius that gives a minimum surface area. I'm running out of room, so I'm abbreviating a lot, because a prime changes from negative to positive at that value. I'll just say there. That is it. First optimization problem ever is done. This was a little more complicated than most. Notice all the work in there, but we had to, again, let's review. 2 things. Had to find what we knew, find what we didn't know, answer the question, read it thoroughly, and sometimes confirm. We won't always do that, but it was a good practice on the first one.